people still filing in. Hi, welcome. I'm here to talk about Kotlin, so let's do that. Kotlin. So a lot of you are probably familiar with Java. It's this language. I think it's been around a little while. Yeah, no, do you know Java? No. I love how their original logo. It's got like a naked woman in there. You know, not PC at all. Brought Java. Java's been around forever. I was using Java while I was still in college, which kind of dates me and Java, because that was like 20 years ago. I think that was Java version 2 when they didn't have, they didn't switch to the dot nomenclature. Anyway, Java. So Java has today over 9 million developers. We don't even know how many there are exactly, because it's kind of hard to count something that's grown so much over the years, and let's just face it, it's hard to count. Get a pretty good guess, though. It's still the #1 most demanded language for jobs today, and easy to find talent because there's so many damn people who know how to do it after decades and decades of using it. It's reliable enough, so why are we changing? Why are we talking about other languages? I mean, what's wrong with Java? Java does it all, kinda. I'm just telling you my conclusion right up front. Languages affect the quality of your code. Languages matter. So let's see. So what's wrong with Java? Why would Java have a quality problem? I could take hands or something, but I'm just gonna go ahead and explain it. So null. Null is a problem. Classes. So there's a thing called final classes and non-final classes. And every time you create a class in Java, it defaults non-final. We'll talk a little more about that. Libraries, we wouldn't be able to produce as much cool stuff as we can today if it wasn't for all the stuff that came before us, all the freebies, it's hard to really recognize how much reuse we get out of our libraries, but you can't extend the classes you got with your library. It is, or it isn't. And if you're lucky, people maintain them and add on where new things are needed. And the code in Java is mostly boilerplate. It's so boilerplate that when you use an IDE, they have special buttons that generate code for you. They wouldn't be able to generate code for you if it wasn't boilerplate. Checked exceptions, and we'll talk a little bit about that more later, but checked exceptions were probably a mistake, almost certainly a mistake. So null. This is a quote by Sir Tony Hoare. To this day, Java developers scream his name when they have problems in production. So he called it the $1 billion mistake. And so who is Sir Tony Hoare? He's the guy who created null in the first place when he was creating the compiler. It wasn't Ada. It was, I'm not going to remember now. Now that I'm live. But of course, he was creating a language. He created null. It was just a time saver for him because he had things he wanted to express that weren't as easy to express without a null in the language. But at the time, he didn't want a language with null in it. It was just a convenience. Well, today it's more than a $1 billion mistake. It's well into the billions. I had to make the Yakov Smirnov joke for a Russian language, of course. But in Mother Kotlin, types default not nullable, if that makes sense. And if you do allow null in your code, that anything that's unsafe that you're going to do will get caught by compilation. This is a crazy concept to Java developers, because we're used to seeing null pointer exception. You don't just see it once, you see it all over the place. And oftentimes you see it mostly in the code that gets used the most often. So if there's a particular nook or cranny of your code, an edge case, and your QA isn't rock stars, you may have null pointer exceptions just waiting to crop up in your code. Whereas catching and compilation is much better. So in Kotlin, we have a whole bunch of solutions. You got the safe call operator, $.. Anything you put after that, like method calls, you can chain. And what it'll do is if it turns out to be null, it'll just do nothing, which, it's better than crashing in some cases. Yeah, I'll explain a little more later. Elvis operator. I think they think it looks like Elvis, the hair. If you look sideways. It's the Elvis operator. Elvis operator allows you to specify what to do if it is null in the case of a nullable variable. Danger will, I named that one myself. I don't know what the actual name is, but if you do double exclamation points, that's how you flag to other developers that this code will blow up in production if there's a null here. That allows you to just very simply say, I wanted to run this, and if it breaks, just throw it, fail and crash. The safe cast operator basically allows you to do a cast without worrying about null. And then you can also filter out nulls and collections very automatically. So if you've done something like Swift, a lot of new languages are using all of these features, and you've probably seen them before. So another thing, classes in Kotlin all default as final. This might sound good or bad. It's nice to be able to extend something, but there's reasons why this is a good thing. Why does this matter? Once a class is open, you can never then close it, because people have built up a dependency like a drug on your class being open. And now that they're using it, you can't just take it away from them without changing all of their code. So other code builds up this dependency on not just your class, but the actual structure and syntax and methods of your class. So in effective Java, which everybody who knows Java has probably heard of at least, they say to design or document for inheritance or else prohibit it. What they're saying is if you don't want to establish this dependency if you're not planning for it. This is something you should be doing if you're creating something like a library for other developers. You don't want your language to make it possible for people to become dependent on something that wasn't designed for that. Boom. But Java libraries are final. Well, most good Java library developers will put a final in front of their classes and be smart and not let you extend everything. So welcome to Contradiction of Java. I can't add utility methods to your library, but if I can also depend on anybody's class signature until it breaks my code. Essentially, when somebody forgets to put final in their class, you get all these dependencies. But then when I actually use a library everybody uses, you can't extend it. Methods are final, types are final, all kinds of, not types, you know what I mean. All sorts of things are final, and then I can't add methods to existing classes, which is crazy. You get the worst of both worlds, unfortunately. So that's why I was meaning about why it's good to have classes default final. Kotlin has extension methods, and we'll talk a little bit more about them later. So here's some random examples of things you could do. With extension methods, you could use the date class in Java and add a is it after the deadline class or a method for your particular problem. You could, if it's Android, maybe you want to add to activity an ability to show a message or something. Or you could take a string and pig Latinize it. The sky is the limit. You can go nuts with existing things that are not extendable using Kotlin. Boilerplate. I actually found this as a book title online and actual book cover. It's pretty cool. History's a mechanical marvel. Let's talk about boilerplates. Everybody's familiar with getters, setters, hash code. These are all equals to string copy. Things that you end up usually generating in Java. Things that you might just hit Control-N and say, do it for me because I don't care. But in reality, it produces a ton of code that may have real code embedded in it somewhere, or things that you might actually want to read. So nobody wants to actually have to write that stuff. Nobody wants to have to read that stuff. That shouldn't really be a thing that you have to worry about. Or you can have data classes. These are a thing in Lombok. They're also a thing in Kotlin. I'll bring up Lombok a little bit later. But the great thing about Kotlin is you don't have to do it all. Your compiler will do it for you. All these things are just magic. And get hell yeah. So Jeff Atwood is one of the guys who made Stack Overflow. He's famous for a bunch of things, whatever. he likes to say that design patterns are symptoms that your language is broken. Essentially, if you've got all these patterns, they require a lot of boilerplate. They all look the same. In essence, if there's a design pattern, it probably could have been done better if it had been thought about in the first place when they created the language. So it seems like it makes a lot of sense. Here's a few design patterns that are just built in. You got singletons, as in, they're just there. You don't have to figure out what canonical singleton method do I use in my Java code, because there's like 20 billion of them. Delegation, built in. You got type-safe builders. Async await coroutines is actually a new thing. They're putting a lot of the asynchronous concepts to handle threading into the language as well. And it's actually in kind of an early phase right now, but that's all there as well. So there's all kinds of cool stuff that's being done for you. Who knows what checked exceptions are? It's pretty good. Okay. So for the people that don't know, checked exceptions are where you put the word throws on a class. You're essentially saying, or a method. Yeah, I think it's a method. You're saying that if somebody calls my method, they have to handle when it errors out. And they have to handle a particular error. So what happens when you use throws? You force the developer who's trying to use your method to actually have to put a try-catch block in there. And what inevitably happens is you get something like this. You try to do something. You try to get your job done because we're all under deadlines and terrible things are happening. And then you have a little catch statement for some horrific exception that could happen in production, doing terrible things. Oops, I went too far there. And then you put a to-do in there. You say, like, yeah, one day I'll write an error handler and I'll write my novel and win the Guinness record and learn the digits of pi or something. The point here is that usually what happens inside this catch block when you're in a hurry is you do one of two things. You print a stack trace, which goes to practically dev null. Or worse, you do this, and you end up with something that in production will not do anything except silently fail and produce downstream failures that you're not aware of or ready for. So this is way too common and causes horrific things to happen. Java's I believe maybe the only language, only one of two languages maybe, to actually mess with checked exceptions, but it was a psychology experiment gone wrong. And I'm glad to get away from it in Kotlin. Other stuff. So who knows who makes Kotlin? So JetBrains is the designer of all the most awesome IDEs, in my opinion. My correct canonical opinion. Because I'm the arbiter. No, okay. Anyway, they make IDEs. So they were the language creators of Kotlin in the beginning. Today, there's a large, vibrant community around it. But Kotlin is heavily supported by JetBrains these days. They're actually trying to do a big marketing splash now that they've seen such incredible growth around what they created. And so any of the IDEs that support Java, like Android Studio or IntelliJ, have really amazing support for every language feature of Kotlin. You're not going to do much better in pretty much any language. It's also 100% compatible with Java. That doesn't just mean like there's interoperability. It also means you've got things like reflection in both directions. You can look into the classes and members of your Java from Kotlin and vice versa. So that empowers you to do things that you wouldn't be able to use with, say, like Groovy or Scala or JRuby or take your pick of JVM language. The JVM and Android thing is, well, that's kind of a given, but this JavaScript thing is new. They were trying to do compilation of JavaScript in the early days of Kotlin. They kind of pulled support early on because they weren't sure they could support 100% of the feature set. Today, they've officially given back JavaScript and said that now we're going to do everything you can compile to JVM will compile to JavaScript, with the obvious exception of Java interop. I think. I believe that's correct. So now you can actually build Kotlin apps for your browser with the same code base, in theory. Fast compile times like Java, one of the reasons they built Kotlin at JetBrains is because they investigated using Scala to do all their IDE work. And they actually, what they found out was Scala has crappy compile times. They didn't want that. They wanted a replacement language because Java just is getting kind of old and bloated. And they got something fast. Lambdas and functions, you get some of that in Java 8, but they're actually a first-class language thing. You don't have to have anonymous functions. Lambdas are actually just work. So I'm doing a lot of hands, sorry. Anyone know what Lombok is? Not too many. So Lombok tries to solve a lot of the problems that Kotlin solves. Not all of them, but a portion. And it solves I say the boilerplate issues. And it solves it by adding annotations that then basically generate code through the compiler at the lowest levels. Unfortunately, so everything that Lombok can do, Kotlin can do better. There's actually I'm going to put this link up here and leave it up for a while in case anybody wants to get it down. Essentially, the problems with Lombok, one, once you get dependent on it, you're going to want it in every single class, or every single project you work on, and it may not be there. On top of that, it breaks at times. Not often, but it does become an issue. And on top of that, any place you would use Lombok, there's shorter versions or better versions in Kotlin. Because most of those things that Lombok can do are built-in language features in Kotlin. Cool. Everybody got the URL if they want it? All right, I'll move on. Let's see some code. So I just wanted to show a very quick example of what interop looks like between Kotlin and Java. And what you can see here is that I'm just creating a very, very simple class in Kotlin. If I want to call it from Java, or no, is this right? Yeah. OK, so if you got Kotlin, you want to call it from Java, you just new your class, and then you call your method. It's actually very simple. The only thing that gets a little funny, sometimes if you want something to be a field in Java, you have to actually annotate it in Kotlin. And anything that's a box type, which is a lot of things in Java, will naturally become nullable if you don't annotate them. Annotations being nullable annotations. I think that's kind of a given. You could say if nullable or not nullable will change the way that your interop works.
Anybody mind if I cut the lights? It's kind of hard to see.
So go ahead, yeah. Does that work?
Half of it.
All right. Cool. There we go. Is that better? All right. So we're going to look at just calling Java from Kotlin. You just import your class, and you can call it directly. And the most important thing is how the types get translated, obviously. And obviously, if you don't do annotations, you're going to have to worry about null checking because Java code doesn't have null safety. And you're not going to get that automatically if you're writing Java. Don't try to look at this too much. Don't try to read it, even if it was in enough pixels. I just wanted to show you what a data object looks like if you're trying to write it in Java. In Lombok, this would be about 4 lines, maybe 5. But it's even better if you do it in Kotlin. You got all your getters here. You've got all your setters for each of those for type, name, and email. It has hash code, toString, copy. And one of the crazy things is copy with changed fields. You can actually copy an object to a new object, so it's a separate instance, not a reference or anything. And the new object can have changes on the fields, which is pretty awesome. Lots of cool stuff. Default parameters. And in Java, you have to do this crazy bean thing where you create 10 different versions of the same function to handle defaults. Has anybody seen this in code before? Yeah. It's terrible. Here's Kotlin. You just specify defaults. Filtering list. These aren't exactly identical. I think this one actually destroys the list as it goes through. Hit that remove. Yeah, that's not going to be pretty. You might want to copy it first if you're going to do this. The Java 8 version actually is reasonable because that's using stream functions to cut it, to filter the list. So these two aren't really identical, but this would get worse, is what I'm saying. This is Kotlin. One thing I want to note here is the top one, you can clearly see the lambda. It's showing like x is greater than 0. Kotlin, like, I hate to compare it to older languages like Perl. They have these things called the $_ and add_ variables. They're default variables. Anywhere you have a single variable lambda, that variable becomes it. So in this case, we're just creating a short form lambda here that makes it super, super simple. Cool. String interpolation. It's not the coolest thing in the world, but it's nice. In this case, you might want to be able to have braces in case your name would look like part of the string, and you can do that. But that's simple. It's not even that cool. Instance checking. Boy, you don't want to do this. just don't even think about doing this. If you're doing this, you're already down some bad street, and you don't want that. This is Kotlin. There's a thing going on here called smart casting. What you're noticing is that after you do your instance check, you don't have to cast anything. It just is. We know it's a foo. Why do we have to cast it then? Kind of simple. Makes sense. Traversing a map. This is all boilerplate. You've seen it a million times. Here's the Kotlin. Yeah. Take a look at joining lists. I mean, yeah, just add them. Sort by property. See, comparators are actually pretty cool. The idea when they came out, you basically got this lambda of sorts inside there. I guess you could shorten this with Java 8 lambda code, but it gets to this in Kotlin. Again, the special default variable for lambda makes this even easier.
So how does that know, what says dot date, how does that know what date to sort by?
Okay.
Higher, lower?
Right. Okay. So yes, I think you can add additional stuff for that. I think there's a default behavior on what it. I think it's by default less than to greater than, but you can.
So,
There's I think it's natural ordering, and you can specify differently.
Okay.
But this is like the shortest possible.
So that is equivalent to
Yeah.
Okay.
Yeah. I think it's natural ordering. Returning multiple values. This is just implementing a pair implementation in Java. You have to create the class and then you put it down as a return type and all that. Kotlin has this thing called destructuring declarations. It looks a lot like, I hate to keep referencing Perl because it's Perl, but you can specify as many destructured variables on the left-hand side, and it can suck in the return value into separate variables. In this case, we actually have a class that takes two values and it destructures it down to its different types. And you can actually kind of dot this if you don't care about one of the parameters. Initializing immutable lists, you have to import Guava. Well, Guava has 15,000 methods. If you're on Android, that's going to suck down a third of your method count right there. This isn't the best example of Kotlin really kicking ass, because if you look at this looks cool. Unfortunately, it's not really immutable. It's compile time immutable, which means we provide special. If you're using Kotlin here, there's compile time guarantees that everything that's done in Kotlin will error out if it tries to modify the list. But if you try to access from Java at runtime, you can get away with doing terrible things. So if you really want immutable, go to Guava, but this is good enough for most of the time. Yeah. Again, this is a map using Guava. This is the Kotlin version. Lazy. So lazy is kind of a useful thing. Maybe you have a particular field or variable, we call property in this case, and you want to, when you call this variable, you want to, the first time you use the variable, you want to be able to set it lazily at that moment. I'm not even sure this is the best example here of doing it in Java, but this is how you do it in Kotlin. So this won't run compute p until the very first time you use p, and then it'll remember the value. thenceforth. So that's really handy. For example, you might have, if you're writing an Android app, which is common in Kotlin, you might want to wait until the view's been set up and then things are not null before you actually run a function. So that's handy. Extension functions. This is one of the coolest things, honestly. If you're trying to do extension functions in Java, you're just going to run into trouble because, first off, a lot of things are final. And then you can't inherit and things blow up. Then you end up with all these util classes, and how many of those do you want to have in your project? Once you get to Kotlin, it's as simple. I want to do string to camel case. I just declare a function on string, and I can use it like that. It just works. Singletons. So this isn't even a canonical singleton. This is just one of many dozens of different variations. This is a so-called thread-safe singleton. I think it's not even thread-safe anymore because this is from like early days. It breaks on reflection, serializable, all kinds of stuff. This is what it would look like in Kotlin. So, yeah. So not null or else. Oftentimes you want to be able to handle the situation that something could be null and what to do in cases where something isn't defined at the point you try to use it. You might not always want to throw in crash in those cases. So we've got pretty blah code, and we got this code. So this is the safe call operator. In this case, if data.email is unset, or is null, in this case, we return print default. Pretty simple. So I'm going to go through a few examples that actually Jake Wharton came up with for things that are a little more esoteric that you can do with Kotlin. So explosive placeholders. In Java, a lot of people will write code like this where you have a to-do. You just want to tell people, hey, I forgot to implement this. This is going to blow up if you try to use it. In Kotlin, they turned that into a real thing because it's such a common need. Because otherwise, people will just put a comment there and it won't blow up. So actually, in Kotlin, if you use this, I forgot to close my braces, I think. Terrible. Bad. If you use that, not only will it blow up with an exception and return whatever's in here, this also works as a comment in your IDE and will actually remind you to do your to-do. So it's just a handy thing. Input validation is a royal pain with Java, and it's probably the #1 source of security bugs. So you got two problems here. One is null, and the second one is dealing with the proper arguments, that you expect to see. You don't have to deal with null in this case if it's Kotlin, because that's just handled. But there's a require, and there's require not null, check not null. All these things are just built into the language for the purpose of input validation. Timing code, for some reason, it's not really difficult, but it's something that some people do wrong. So they just built it in. There's a measure time millis, measure time nanos. You can just throw things in the block and it'll measure whatever you do. Handy, not amazing thing, but it's just useful. Deprecation level. So this is a strange one. In Java, if you put a deprecated annotation at the top of your class, what it does is it basically does a lint error if you try to use it to tell you, hey, this was deprecated, you might not want to use it. But it leaves you dying for documentation. It doesn't tell you what to do, like if there's an alternative. It doesn't help you in any way, really, except to say there's something wrong with what you're trying to do. So in Kotlin, they decided to make this stronger. It's a mandatory string to tell the user what to do with the deprecated class. There's also deprecation levels, which allow you to phase out the functionality over a series of releases. You can go to error, where it no longer just warns the user, it actually crashes, or doesn't build, rather, excuse me. There's hidden, which will actually keep existing codes working if they were built with that, but will not let new users use it.
How does that work?
That's a good question. I'm not a pro on that one, but I do know that it's basically, it turns up red if you try to use it in your compiler, and it's one of those things where the symbols are there, but it doesn't light.
So is it like an IDE function maybe? Or
I think it's like an IDE function. It's basically to tell the IDE, don't let them know it's there, but it's there. So deprecation hidden is a trick to kind of phase things out at the last stage before you kill them completely. You stop getting new users. There's another thing which is even beyond that, deprecation auto. So this actually takes the thing the user tried to use and then replaces it with the thing that's now the recommended solution. So you can actually have, if you do, say it's Android Studio or IntelliJ, you can hit Option Enter. It'll actually do the replacement for you of all your deprecated classes. So in this first example, we're trying to deprecate a function to join strings, right, called function join. And instead it says, let's use this function instead. So this will actually take the variable strings and the variable sep for separator and plug it into the new function as an automatic fix, an auto fix, as they call it in the IDE. This one's even crazier. So you can even use imports with the automatic fixes. So here they're saying, well, I don't want you to use my function anymore. I want you to use guava. So I'll have you import guava. You know, if it's in the class or in the if it's in the class path, this will just import guava and use it. Pretty cool stuff. So automatic. What? Sorry.
If it's not in the class path, it just doesn't compile then?
I don't know that one. I actually haven't played with it. I've just it just looks really cool to me. I know that sounds bad, but I'm a new Kotlin user too, and I'm excited about this stuff. I have a T-shirt. Yeah, no. Actually, I was supposed to have stickers for all you guys, but they didn't come from Russia in time, so they'll be along. Example of how to do delegation in Java. Royal pain to have to actually run through the delegation pattern. It gets a lot easier in Kotlin. So the by operator here is what the real magic is. It makes these interfaces now delegate to whatever you pass in. So that's pretty slick. So let's see. I don't know. Languages affect quality. And using Kotlin in your code will improve the quality a certain amount. On top of that, it means there'll be less boilerplate. Less boilerplate means you're going to have less opportunities for failures because you botched up some bit of code somewhere. So how many people would be interested in a Kotlin group if there were one started? Want to get a look? Pretty cool. I actually just today started up a meetup group for Twin Cities Kotlin user group. You can sign up on there. I don't know how soon we're going to have our first meetup, but I want to start getting interest and start building something. JetBrains is actually, they're putting money into this, even though they're not making money off of Kotlin yet that I'm aware of. So they're looking for cities to start their own user groups, and they're doing a thing called Kotlin Nights, where they're going to do, each city is going to have a 3 to 4 talk, like one night conference kind of thing, just to introduce Kotlin. And I'm hoping we can bring some Kotlin celebrities like Andrei Breslov from Russia, maybe Jake Wharton. We'll see who we can get. Somebody big and then we're also going to get people from the community. And we want to get anybody who's interested in talking about Kotlin to be able to come out and say what they have to say. I'd like to make this a thing because obviously Kotlin is, well, in the last year, it's grown exponentially. They went from 2 million lines of code on GitHub. I hate using lines of code as a nomenclature for popularity because this is a very terse language. But there's 2 million lines of code on GitHub at the beginning of the year. They ended it with 10 million. If you actually look at a curve, it's exponential for the last year. We're hitting this inflection point where I think Kotlin is going to be the next big thing. And because it's so similar and interoperates so well with Java, the most popular language, I think it's worthwhile to get something going so we can all kind of teach each other how to use Kotlin better. Yeah. So I'll take some questions.
So you can use this on a class-by-class basis, say an existing Android application, you just replace a particular class that would give the most benefit?
Absolutely. Not only that, if you choose to use it, JetBrains in their IDEs provide an automated conversion utility. Now I have to warn you, it's young conversion utility, and I've been warned by people who have used it, and I've seen it myself, that things that come out of the conversion utility generally require massaging, and maybe in some cases quite a bit. But as things stand today, yes, people are using it as one little class or two classes in a larger Java project or Android project. It's very popular in Android because early on it came with lots of utilities for making Android projects easier. There's Anko, the Android Kotlin extensions. There's, I'm not going to remember everything, but the point is,
Is that a library you have to import?
I think Anko you have to import, but it provides a lot of really neat things that are specific to Android. Lots of things. I can't remember all of them off the top of my head, but one of the things that some people like is being able to, instead of having XML layouts, you can have a DSL at the top of your class to provide the layout. And it does compile time checking on your DSL to make sure it validates. Kotlin is a very strong language for DSLs. Domain-specific languages. Thank you. God. I'll take another question. What do you got? Testing, yes. Oh, God. There was a specific talk on Android or Kotlin testing, and I meant to watch it for today. I've heard great things about it. Does that help?
It has tests?
Yes.
Okay.
Yes, it has tests. Yeah, go ahead.
So I've been coding in Groovy for the past year or so, and like I'm 100% convinced that it's time for me to move on with Java. Like the quality of the code that I can write in Groovy is just so light years ahead of the quality of code I can write in Java.
Yep.
So I'm sold, right?
Yeah.
And I'm convinced that one of these JVM languages is going to be the next Java, right? It's got to be interoperable with all the Java code that's out there already.
Absolutely. Yeah.
But I'm a little overwhelmed by all of my choices, right? I've got Groovy, I've got Scala, I've got Kotlin, I've
Oh,
got
yeah.
Clojure.
Yeah.
I've played a little bit with all of them except for Kotlin, but for name's sake,
Yeah.
everything looks wonderful to me.
Oh, yeah.
Who's going to win?
Who's going to win? Well, you know what I'm betting on.
And what's the long-term viability of whichever one you end up choosing?
Well,
Groovy
with any so.
and dark period.
Sorry, I don't. This is like an unconference. You should all be talking. The crazy thing about any technology is the viability of it is dependent on who's supporting it and what they're doing with it. Like, for example, the reason why Swift is so big on Apple is because Apple is the backer. You know, Kotlin has somehow miraculously hit exponential growth on both server and Android, in spite of Google saying, whatever, you know, do what you want. It's not official, you know. Kotlin somehow is defying all kinds of constraints that usually would hold a language back. So I think once it hits its stride, it will really pick up. You know, it'll really, take over the industry.
Does it have, I mean, you compared it to Lombok, but does it have advantages over those other languages?
So that particular link for Lombok was showing you how it's better than Lombok in each case. So each of those other languages, some of them provide some piece of it. I think it's really hard to compare it to every language.
Sure.
Because I don't know every language. I know quite a few. Scala is very complex, long compile time. Groovy has, if you try to include it in an Android project, you get like a big dump of extra crap that I don't want to be mean to it, but it's,
No, you have to include a lot.
you have to include a lot.
It comes with a lot.
Yeah, it all gets imported in, and you get all these methods, and it's a little heavyweight. Compile times aren't that great in Groovy, but it's a useful language. I mean, I use it for builds every day because it's Gradle, you know?
I think the integrated ID support is pretty much what's driving the adoption right now. Like for instance, with Ruby, one of the issues I've had with it,
Yeah.
even like using it in Eclipse, let's say, for instance, is so you get a plugin that hasn't been maintained for 4 years from
Yeah.
somebody, you want to upgrade to 2.4, but the plugin doesn't support it yet.
Mm-hmm.
And if you refactor your Java code, it doesn't find the places where you build those methods from when you wrote it in Ruby.
Yeah.
And so then until you run your stuff and then stuff blows up. So if I've
Yeah.
got just interop problems like that. If
Yeah.
JetBrains solves those issues, then the adoption will go up. Otherwise,
Yeah.
I mean, I don't know if language specifically, I don't know if it's any better than Ruby. I think it's just that.
That's a good point.
It's how much easier
Yeah.
is it to work with from like IDE builds,
Yeah.
those kind of things.
Having JetBrains literally all in on this, like plowing money into it, anomalies that show a great strength of support, but as a partner, JetBrains is one of the top IDE companies today, by far. So that really gives it a lot of oomph.
If you do like a mixed project
Yeah.
with Java and Kotlin,
Hmm.
does it complicate the build process at all?
Does it complicate the build process? I don't
Build scripts or
believe.
anything?
I
So-
don't
so
know
you-
if you can take answers from the peanut gallery, but
Okay.
I've been using Kotlin for probably about 2 years. I am not as knowledgeable as you, Colin, but
Sorry.
it's-
You're smart. I'm not gonna.
It's pretty much seamless. So like I was gonna say, if you want to dabble in Kotlin, my only experience is with Android, and it's the language of now. It's a very pragmatic language. It's not a theoretical one, and I've seen it evolve from what they wanted to do with people using in the real world. I mean, it has to be interop with Java. The tool support, because it's from JetBrains, is flawless, and it works really perfectly with Gradle. But what we did, I work at BuzzFeed, and I couldn't quite sell using the APK code base with Kotlin. I probably would have lost my job with it, but we wrote all our tests in Kotlin.
Yeah.
And I did, and it's there, it's now, and but yeah, I think until Google officially endorses it. But what I was going to say, if you want to dabble with it, there's like 8 zillion projects out there. Just download one
Yeah.
and start hacking. I
Exactly.
mean, it'll take you probably, what do you think, Colin, 10 minutes to get the basic gist of that.
Yeah.
You have val and var, which is a value variable if it's final or not, and it's just so intuitively obvious, and so I'm a very biased observer, of course, but
No,
I
no, no.
love Ruby. I like Groovy on the server side. That's really strong. But I believe Gradle now, you can write your Gradle scripts in Kotlin.
Yeah.
And then
there's a lot of
JetBrains
crazy
eats their own dog food. They write all their IDEs in Kotlin. So.
But by the way, if you're writing for Android and you're using Android data binding, you're using Kotlin to generate all the classes that are coming from data binding, because that's that Google. If you take any giant company, by the way, I work for Amazon. We're hiring here in Minneapolis. If you take any giant company, there's going to be some places that are using Kotlin today, and whole other parts of the company that aren't even aware of it. And so you see this phenomenon where it grows because the biggest thing holding it back is lack of knowledge about it. People not really hearing the stories of where it's succeeded. And I think that's the reason why they hit this exponential growth in the last year, is that now people are talking about it a lot more, even before JetBrains started doing their push. And yeah, don't sell yourself short, Steve. I feel like there's a lot of imposter syndrome in this industry. Like, lots of smart people give talks, and a lot of this is borrowed in some sense from some other person, because that's just the nature of it. Yeah, if I wasn't standing on the shoulders of giants, the people who came before me, this would be a really short talk. Don't sell yourself short, guys. We all have to kind of fake it before we really understand everything in our language that we're talking about. Yeah, go ahead.
What's the release cycle of Kotlin like? Because with Java,
Yeah.
Android's had an issue because Android didn't keep up with the Java language functionality. Java 9 right around the corner.
Right.
How is Kotlin poised to kind of take advantage of the new language features?
Well, clearly, one of the problems is that nobody wants to build to Oracle stuff, because there's certain legal implications to that. And actually, Android is building to OpenJDK. They're not even building to Oracle anymore. They're headed that direction. It's great to be able to compile to a particular target rather than a moving target. So that's one advantage for Kotlin, is they can compile down to Java 6 if they wanted to, and they do. And they get all the functionality of lambdas without any anonymous functions whatsoever. And one of the things I forgot to talk about, I probably should put in there, was inline functions. In Kotlin, you can literally have a function that will inline itself at any call site, which means that you can get the performance of actually having just written the code while actually using functions, or believing you're using a function. So that's another advantage of Kotlin, is there's a lot of things I forgot to put in, and actually, if you dig into Kotlin, you'll find some of those things. I guarantee it. Yeah, no input detected. Yeah, did I answer your question?
Yeah.
Okay. Yeah, sorry.
In Java, enterprise Java world, right? It's all about ecosystem, right? How does Kotlin play into that ecosystem?
Into the enterprise.
Enterprise Java.
Java Enterprise. Okay. So you're talking about like the Java EE kind of thing.
Right, lots of library, right? Like Spring, Hibernate, right?
Spring has native support for Kotlin now.
Yeah.
It's actually no like this is like libraries like Retrofit and I think of requery and all these there's all these awesome libraries that are like the state of the industry right now that are jumping on Kotlin and doing it as either a second party or first party to Java, and that's really encouraging to see that the most interesting libraries have all jumped and said let's do Kotlin because we think this is going to take off. Go ahead.
So are there any pain points that you have when you're getting started in Kotlin, or is it just all beautiful?
So any pain points getting started in Kotlin? If you're doing interop, so interop is usually the first thing you do because you have existing code and you want to support it, and you want to get moving. One issue that you have with Java, I mean, obviously Java has null safety issues, and if you're using Java in Kotlin, you have to, appropriately use it. There's another issue, which is type erasure. Type erasure is where you have a generic type and you want to use it as a specific type at runtime. And if you're trying to use that generic type across the interop barrier, there can be some issues there, I think. They're working out details there. There's also, if you're interested in the async await coroutine stuff with parallelism, that stuff's a little young. They're still firming up the how it's actually going to play in terms of syntax. So if you try to use it now, they might change it underneath you in your code. So those are two things you might think about. Is there's a few edge cases where the language hasn't firmed up completely, and type erasure is something you have to think carefully about. Go ahead.
Any performance benchmarks specifically against Java server side?
That's a good question. I feel like the Java performance is comparable. Obviously, if you're using inline functions, you're going to get better performance than using a function. But in terms of compile time, it's roughly equivalent on Android, at least, I know. I imagine the same would apply to server. Go ahead.
Is there any RX Kotlin yet?
Oh, yeah. Definitely there is reactive programming. I don't know who's familiar with reactive programming. I'll explain it a little bit then. So the idea of RX is that you want to have the ability to do functional programming, streams where you have a stream represents a series of events or data events that occur over time. And you want to be able to, every time an event occurs, react to it by running a function or a series of functions that transform it. So for example, you might have an event where you say, give me the latest thing off the network, and then, or let me do it differently. You might say, like, give me the most recent thing, either from memory or disk or network in that order. And if anyone has one that's current enough, send that back to me. Well, that's really hard to do in just basic Java or Kotlin code. Even in Kotlin with async await, I imagine there's some difficulty there. So RX makes it simplified to deal with asynchronous events. By using functional programming, you don't have these fields that can get out of state. You're no longer carrying around all these state variables that are going to break in a million ways because you didn't set them at one point. Is that a good explanation? Make sense to people? Yeah? Okay. Basically, it's a way to eliminate state, eliminate what's called callback hell. You use a lot of callbacks for asynchronous programming. Deals with a lot of problems, really. So yeah, RX Kotlin is a thing. It's well supported. Another question? Yeah. Well, I think we're looking good on time. Yeah, cool. Don't forget to sign up if you're interested in the meetup.